The idea behind our project is to create a remote-controlled tank. This tank's main goal is friendly and enemy target acquisition. This is achieved through a laser diode and phototransistors, as well as a camera that works in conjunction with an image recognition system. Our team aims for the broader impact of photo tanks to assist in the prevention of fratricide amongst our armed forces and our allies, as well as to improve the current target acquisition methods utilized by our military. The project implementation plan was to test each component of the tank individually and then merge them all into one finalized project and finalize the connection between each unit.
Hello, my name is Joshua Walton. I'm a photonics engineer. I generally worked on everything done in this project, but I focus mainly on the optical and administration stuff.
Hello, I'm Dylan Krakowski. I'm a photonic engineer, and on our project I focused on a lot of the optical design and all of the mechanical design.
Hey, I'm Joshua Frazier. I'm a computer engineer, and I pretty much worked on anything that dealt with code on this project. Dipped in with some of the electrical circuits, but not anything too crazy.
Hi, I'm Skylar Burns, and I'm an electrical engineer, and I work on the PCB as well as other electrical research for the project. Here we are going to display the mobility of our tank. So here we have forward movement, reverse movement, turn to the right, turn to the left, and all of it together. Here we are going to demonstrate the climbing capabilities of the tank. After doing the climbing demonstration, we found that the tank can only climb roughly 2 millimeters. If we include Dylan's fingers, which got ran over, then we're at roughly 3 millimeters. Now we will demonstrate the turret rotation. So we can move the turret to the right, to the left, and as you can see, we have a full 360-degree motion. Here we are demonstrating the barrel elevation servo motor of the tank.
For our laser system, we used a Thorlabs MLD series evaluation board to regulate temperature with a constant current driver chip. In our barrel assembly, we have an LA1039 plano-convex lens with a focal length of 9 millimeters to collimate our 635 nanometer laser diode. As seen, we have a fairly clean beam spot at a distance of about 1.5 meters here, and about 2 meters. And then this is probably more like 2 meters. And then moving out to a distance of about 4 meters here, we still have a fairly decent beam spot. It's starting to widen a bit, but it's still clean and collimated. Then moving out to a distance of about 8 meters here, we can see that the beam spot is starting to spread out further, but it's still fairly collimated and clean and circular. We have a fairly clean beam spot at a distance of about 1.5 meters here, and about 2 meters, and then this is probably more like 2 meters, and then moving out to a distance of about 4 meters here, we still have a fairly decent beam spot. It's starting to widen a bit, but it's still clean and collimated. Then moving out to a distance of about 8 meters here, we can see that the beam spot is starting to spread out further, but it's still fairly collimated and clean and circular.
Here we are going to demonstrate the phototransistor-based target identification system on the tank. As you can see, when the first phototransistor is hit by the signal, we get a green LED indicating friendly. And when the fourth phototransistor is hit by the laser, we get a red LED indicating that that's an enemy. Here we are demonstrating the target acquisition software built into the tank system. As we can see, it's picking up multiple team members and identifying them as people. All 3 team members have been identified as people. And the chair has been identified as chair. Our team feels that the key to our creative collaboration and successful teamwork was rooted in our communication, especially given that we weren't always able to group together and work hands-on. Right away, at the start of Senior Design 1, we established to have weekly meetings online to maintain an open dialogue between us. Proceedingly, we were able to smoothly conceptualize, research, plan, and execute our project. The greatest challenge that our team faced during our planning process was when we came to the sudden realization that our 2 GB Jetson Nano was not capable of being trained. We were having memory issues, overflowing what the Nano was capable of, resulting in it crashing. This was a serious problem because in order for our project to have target acquisition, it needed to be able to perform image detection. The obvious solution to this problem was to upgrade our Nano to the 4 GB version. However, this was impractical because of the $600 price tag. Exploring possibilities, we found that we could utilize pre-trained architects to fulfill our image detection. While our target acquisition component of our project didn't transpire to what our team envisioned, we were able to construct a proof of concept to demonstrate target acquisition. There are a few things that motivated our team to remain focused and see our project through to completion. The first being quite simple. We all enjoyed the idea of our project and found it rather easy to be inspired and motivated. The second being a bit more sentimental. This project is like our child. We've conceptualized it, designed it, built it, and gone through the moments of rejoice and anguish. We wanted nothing more than to see our project finished and working hard in the end. We had no stakeholders for our project. All decisions made were of our own. However, we heavily considered feedback from Dr. Ritchie, Dr. Wei, and Dr. Carr. The most important lesson we learned throughout the project process was the active planning ahead for potential problems and failures. Not that our team didn't have backup plans for nearly everything. There were still a handful of cases where we had to think on the fly and adapt. Reflecting back, if we had established contingency plans ahead of time for when it felt like our backs were against the wall, then we would have been more prepared for these situations. Initially, the first notion of our particular project stemmed from the idea of first-person tank laser tag. Progressively, we became more motivated as we expanded the idea out towards systems that could be applied to full-scale military tanks. Upon our research, we found that fratricide by misidentifying friendly armor as hostile was a prevalent issue, and the U.S. military had called off any research and development technologies similar to our product.